But this one's a pretty sophisticated problem. So you got the cube root of 5 times the square root of 5 cubed, and you're simplifying it. Let's probably convert it into exponential form. So let's go 5 to the 1/3 times 5 to the 3/2. So I just changed both of those to their exponential forms. Now, when you're multiplying powers with the same base, you just keep the base. So if the base is 5, keep the base, and you add your exponent. So 1/3 add 3/2. And you can't add fractions unless you've got a common denominator. So what's the least common multiple of 3 and 2? You're going to have to change them both into sixths. So how many sixths is 1/3? 2/6 is 1/3 plus 9 sixths. Alright. So move number 4. Let's add 2/6 and 9/6. You're going to have 5 to the 11/6. And then move number 5. Let's go ahead and let's morph it back into radical form. So you're going to have a radical. Your radicand is going to be 5. The exponent is 11. And your index is 6. Okay, and then always look at it and see if you can simplify it. What's 11 divided by 6? It's almost 2, because 12 divided by 6 is 2. So it is 1 and a remainder. So if it's at least 1, that means one of these 5s is coming out. And how many are left in there? 6 times 1 is 6. 11 minus 6 is just 5. So the remainder must be 5. 5 to the 5th under the radical. And on the outside is a 5. That is your answer. So if they want you to simplify it and they give you radical form, your answer's got to be in radical form, but along the way it made it pretty easy to change them into exponential form. That's a good problem. Okay, now this one specifically tells you to write it as a radical. So 6x to the 5/3, be really careful, because this is 6 times x to the 5/3, and that 5/3 is only going to the x, it's not going to the 6. So your answer is going to be, the exponent of the 6 is just a 1. So it's going to be 6 times the radical x to the 5th with an index of 3. So it's a cube root of x to the 5th. Okay, let's see if we can simplify it. Can you do 5 divided by 3? Yeah, you can. You get 1 and a remainder. So that means some x's are going to come out. How many 3's are there in 5? There's 1, so it's going to be x to the 1 makes it out. And how many's left over? If you take a 3 away from 5, there's 2 left over. And you got to put cube root. So your answer is 6x times the cube root of x squared. Okay, imaginary numbers. This one is a subtraction problem. So what you got to remember is this. I is the imaginary unit, and that is equal to the square root of a -1. Then I squared is equal to a -1. And this is the one we love, because we can take an imaginary number and it relates to the integer -1. So our real number -1 is the same thing as an imaginary squared. Okay, so you add, subtract, everything really similar to how we do real numbers. First of all, I'm going to take this negative to the 7, and I'm going to change that to a plus. Okay, now you just add them. So -6 minus 7 is a -1, and a -4i plus I, there's the invisible 1 in front of that. So -4i plus I is a -3i, and that's your answer. 33. Similar to our irrational numbers, you cannot have an imaginary number in the denominator. So I'm going to times it by 1. I'm going to times it by the conjugate of a -3 minus 5i, which is just a -3 plus 5i. And I've got to times the numerator by -3 plus 5i. Okay, let's do the numerator first. So 5i times a negative 3 is a negative 15i, and 5i times 5i is going to be 25i squared, but I squared is equal to a negative 1, so let's change that. 25 times a negative 1 is just a negative 25 minus 15i. So we put the real number first, the negative 25, then the imaginary number, negative 15i. Okay, that's my top. Now my bottom, since I know that the middle terms are going to cancel out, I'm just going to multiply first times first, negative 3 times negative 3, and that is a positive 9. And I'm going to skip all the next, and I'm going to go last times last. A negative 5i times 5i is a negative 25i squared. And then I squared is equal to a negative 1. So a negative 25 times a negative 1 is equal to a positive 25. So this is what it looks like. It looks like 9 minus 25 times a negative 1. So I'm going to replace that I squared with a negative 1. So negative 25 times a negative 1 is a positive 25. So I've got 9 plus 25, which is 36. No, not 36. Is it 34? 34. Okay. Now, look at your numbers. 25, 15, and 34. Do they have a common factor? Can you simplify them? And I don't think you can. So we're done. We'll call it good right here. This is your answer. 35. A negative 6 divided by 2i. The only problem is, in the denominator I've got an imaginary number. And remember, I times I is equal to I squared, which is equal to a negative 1. So that negative 1 is a real number. It's an integer. So I'm going to multiply the top and the bottom by I. And let's just, this negative out front, I'm just going to write it up with the 6. So I'm going to have a negative 6 divided by 2i times I over I. Okay, in the numerator, you're going to have a negative 6 times I, which is a negative 6i. In the denominator, you're going to have 2 times I, so it's going to be 2i squared. And I squared is equal to a negative 1, so you're going to have negative 6i divided by 2 times a negative 1. So you're going to have a negative 6i divided by a negative 2. And you can simplify this. A negative divided by a negative is a positive, and 6 divided by 2 is 3. So your final answer is 3i. Okay, last one. I to the 28th. Simplify this. You're always on the hunt for this. You know I squared equals to a negative 1. So I'm going to rewrite this as I squared raised to the 2 times what is 28. 2 times 14. So what's your power properties? I know that if you raise an exponent to another level, you multiply those two exponents, and I need to get 28. So 2 times 14 is 28, and I've got I squared, that's a negative 1, so negative 1 to the 14th power, negative 1 times itself 14 times, is going to end up a positive 1.